Alright, so today we're going to introduce our idea of, well, a periodic function, I guess. So, what is a periodic function? So, a function is periodic if it has a pattern of y values that repeats at a regular interval. So, one complete pattern is called a cycle, and a cycle may begin at any point on the graph. The horizontal length of one cycle is called the period of the function, and the period of the function right here shown is actually 4 units. So if you know what I mean, so let's start here. So we'll find here, and then we'll try to find the next exact value here. So this is one loop. So each loop is 4 units long. And then let's talk about amplitude. In any periodic function, the amplitude of the function is defined as half of the difference between the maximum value and the minimum value. So basically, imagine we have a function here, and in the middle we have a line, which usually we do. So like this is our axis, and then I have this line here. And then I'm going to have this function that repeats itself over and over again. So this line, okay, so let me just try to draw this better. So I have this function that repeats itself over and over again. And this is the axis that it's kind of spinning on. So basically this is its axis that is going to keep on repeating itself on. So this is the maximum value, this is the minimum value. So between these, we have this axis. This axis is in the perfect middle of them. So for this part, this is the amplitude. Or you're talking about from this part, from the axis to the highest part. So it's either from the lowest part or to the highest part. This is the amplitude. Okay? For the function above, we have -1 as the lowest value, and we have 3 as the highest value. So our axis is right here at 1. Because to find our axis, we're going to go ahead and do to find our axis, we're going to do the highest number, and we're going to add, well, minus the lowest number. So 3 minus we're going to add the lowest number. So 3 plus -1, it's going to go ahead and give you 2. And then we divide that by 2 to find the middle number in the middle. We're going to be able to see the axis. And then from the axis, we count 2 units up. So for this function, the amplitude is 2 units. So let's go ahead and do some examples and practice. So determine whether each function below is periodic or not. So first example, we're going to go ahead and look. So this function, it rises up. It follows a certain pattern, but it doesn't repeat itself. So no, unfortunately, A is not a periodic function. B, we look at it. Is it a periodic function? And you see, so it repeats every 5 units, and then wait, does it not repeat every 5 units? So this is -2. Oh, every 6 units, and you're like 4 plus 6, 10. Wait a minute. Does this check out? Let's check this. So from 0 to 8, that repeats once. Okay, sure. So from 0 to 8 repeats once. So the period is 8 units. And yes, this is a periodic function. So let's go ahead and check this. Find function values by using this graph. So obviously we did functions before, and we know how to plug values in. So f of 6, if we look at the graph directly, we're like looking at 6. That's -1, which is right there. So right there, that's -1. So f of 6 is equal to -1. And then let's look at how long is our period. Well, from 0 to 7, right? That is our entire period. So let's do 20 minus 7. Because we want to try to reduce this 20 so we can find it on this graph. So if we minus 224, this is going to give us 6. So essentially f of 20 is still going to be -1, right? Because we want to find it on our graph. We're trying to reduce it. Because technically, this, if I have this pattern of, like, let's say this, right? After 20 loops, it's still going to have the same y value here. So if I minus, for example, a full loop minus a full loop, I'm going to come back to this point, right? So we can simplify these to find it on our graph. Now we're going to go ahead and try to do a word problem with this. Andre is jogging on a straight boardwalk beside the ocean. The boardwalk is 800 meters long, and Andre begins jogging from one end at a steady pace of 8 kilometers per hour. Graph Andre's distance in meters from his starting point versus time in minutes for length from the boardwalk. Okay, so let's understand what this question is asking here for. So it's asking us, well, distance in meters from his starting point versus time. So obviously, his distance is gonna be fluctuating, right? Because he's gonna go far from the boardwalk, so he's gonna go steadily up. Since he's moving at a steady pace, he's gonna go. He can travel 8,000 meters per hour. So therefore, in an hour, he can do 10 runs. So let's graph this. So he's gonna travel 800. He's gonna come back. 800 again. Come back. Oh, that's the. Let's go ahead and fill this in. So this is time and this is meters. So the domain and range for this function. Domain x can be any function. So x must be greater or equal to 0, and then x is a real number. And then range is y. Y is so limited. So let's do 0. We cannot be like below. We cannot like be super close, so it's a negative value. So that doesn't work. 0 or less than 800. Because the maximum you can get is 800 meters away. Y is a real number. Right? So this is how we're going to do it. This is how we're going to approach it. And then let's go ahead and look at the amplitude. So the amplitude, the maximum is 800. And the lowest is 0. So plus 0. That's going to go ahead and so divided by 2. So we can find the middle point. This is going to go ahead and give us 400. So our amplitude is 400 meters. So let me just write that. Amplitude 400 meters. And then our period is how long does it take for us to get there and get back, right? So 1600s. So 1600 meters. So we have meters here. And remember recall we had a v equals dt. Velocity equals distance traveled divided by time, right? So we're trying to find this time, right? So t is equal to dv. So the distance that we want to know is 1600, and his velocity is 8,000 per hour, right? So we're gonna go ahead and do 6,000 divided by 1,600 divided by 8,000. It's gonna go ahead and give you 0.2 hours. 0.2 hours, we're gonna time that by 60 minutes, right? Because we want to know how many minutes is that. So 60 times 0.2 is gonna go ahead and be 12 minutes. So we can go ahead and write for our period 12 min. And there we go. That is the entire question. And now let's go ahead and do some practices on the right. On the top, they want us to judge if this is a periodic function or not. For this first one, I'm gonna say I'm unsure. So I say unsure simply because I don't know what's going on. Does these go on or does this go down? So judging by the arrows, I'm assuming they go continuously. So if that's the case, no, it's not a periodic function. But if it goes down and then goes up again, yes, that's a periodic function. This is not the periodic function because the y values doesn't fluctuate. So period of this is we see the lowest point, and we go from one high point to another high point. So let's see. So let's just start from here. So from a little over here to here, or we can start from this point. So this is gonna be 2.5. Is this 2.5? Or I believe this is 2.5, right? Or is this different? So that would be, so if I start from here, 1, so 0.5, 1, and then 2.5. Yeah. Okay, so this loops every 2.5. Yep. So the period of this is 2.5 units. The amplitude, it's going to be 1.5. Oh wait, no, this is 4. So 4, 2. And then the lowest value is -1. So we're going to try to find the middle value. So 4 plus 1, 5 divided by 2, 2.5. Nope. 4 minus 1, 3. 3 divided by 1.5. Okay, so yeah, that makes sense. So 1.5 is our axis. So 4 minus 1.5, that's going to be 2.5. That's our amplitude. You can go ahead and do these. And so is that. This one's a little hard though, so keep in mind. Let's do communication. Spectrograph of, okay, so I'm just going to do a simple basic graph. 6, -6, 12. And our amplitude is 4. So let's just do this. Sorry. Okay, I'm trying to draw better. Okay, and this is 4, -4. So that is my answer for question number A. Obviously, this one, there's variations. I could draw a different one than you. Okay, and then this one is also drawing that, so you actually have to draw it out yourself. Yep, you have to draw that out for yourself. And then this, determine the maximum value, which is 4. Minimum value, which is 0. Period is -4, 8. And then the domain is x is a real number. X is, oh wait, no. So -4 is smaller or equal to x is smaller or equal to 12. And x is a list of real numbers. And then for the range is that 0 is less than y is less than 4. Y is a real number. And then for B, you can go ahead and crack that on your own. And that is our introduction to periodic functions. Next class, we're actually going to go ahead and learn some sine and cosine and hopefully tangent